Welcome back to the second tutorial of Hypertrial Stacking Sat Challenge. In this video, I'll build on the concepts that we discussed in the first tutorial to introduce the problem statement behind this challenge. Quick note, we'll be working on this problem statement through various formats, including challenges on Hypertrial, but also through capstone projects with our university partners. So to keep this video general and applicable to a broad audience, I will focus on the machine learning problem at play. And anytime we get to some details that might be challenge specific, I'll try to provide a quick disclaimer. Now, continuing where we left off, we saw that the question of how do we accumulate Bitcoin over time is typically answered with dollar cost averaging. And that simply means purchase Bitcoin at fixed amounts over a regular interval. That's where the word uniform came in to describe this vanilla approach. But we saw in that previous tutorial that a more dynamic approach that enabled variable amounts, dynamic amounts to be purchased every day outperformed the uniform approach and allowed us to get more bang for our buck and ultimately more Bitcoin. And this is what the core problem statement is all about, is how do we generalize dollar cost averaging to enable us to accumulate more Bitcoin while still preserving its core benefits, namely the systematic and consistent purchases. Now, turning that into a machine learning problem statement is rather than cherry picking the decisions of how and how much to purchase, you want a model to make an informed decision on each day how much should you purchase. One detail is that we're going to move away from dollar denoted budgets to a normalized budget of 1, denoting a proportion. So this abstracts away any specific budget. Your code in your model doesn't have to state a global variable that defines a budget of 100,000 or 10,000. This essentially works with any budget with some disclaimer that we'll talk about later, namely the slippage. And the problem statement becomes, how do you map features to these weights, which denote your daily portions of your entire budget of 1. Now, this is a detail that's specific to one possible challenge, is that the features must be derived through historical Bitcoin price data. In other offerings of this challenge, there might be more data for you to play around with, but for now, these decisions are going to be purely based off of price. So some features to work with might be volatility, for instance, or the moving average of the price. And also another detail that's specific to this challenge is that the parameter that's relevant for dollar cost averaging is budget, which we already discussed, and we're going to take it to be normalized to 1, and also the duration, we're going to take that to be 4 years. And that's relevant for Bitcoin due to its inherent 4-year time horizon, its inherent 4-year seasonality. Every 210,000 blocks, Bitcoin goes through a halving cycle, and this is a key reason as to why we picked this 4-year cycle. The objective, the unconstrained optimization aspect, is that you're going to want to get the highest SPD percentile, which we talked about in the previous video, across 3-4-year cycles, ranging from this backtest period, starting from 2013 to 2024. So using the 4-year cycles that we defined earlier, this backtest period gives us 3 separate cycles to consider our bang for our buck, or how well we accumulate Bitcoin relative to the best and worst possible ways that you could possibly do it. So if you want more clarification on this, watch the earlier video. One thing that I will add here is that your strategy's Satoshi per dollar value is going to be a weighted average of all your purchases, all your daily purchases. Each time you purchase Bitcoin, you're going to get some Satoshi per dollar value. And of course, with a dynamic approach, you're going to be purchasing variable amounts. So this is simply going to be the weighted average of all your purchases across your cycle. Now, that one disclaimer that we were going to mention is that the budget that's normalized to 1 to denote a proportion is great because it abstracts away the necessity to specify a budget, whether it's $10,000, $100,000, or $1 million. But the limitation is that when the budget gets to a certain threshold, slippage starts to become an issue. And for this challenge, for a specific challenge that we're talking about, slippage is likely not to be inside the scope of this challenge. So we're going to assume that the budget is variable, but not going to be problematic in terms of slippage. But as we said, this is a nuanced problem. This isn't just an unconstrained optimization. You have to optimize your model subject to these constraints. This is how we impose the DCA aspect of your strategy, hence why it's still a dynamic DCA accumulation strategy, which is every day you must purchase Bitcoin. And not only should it be some amount, it should be some amount that's greater than or equal to this minimum threshold. The reason why we enforce the weights to not only be strictly positive, but to be greater than or equal to this minimum threshold is to avoid any sort of floating point errors. Next, we must use up our entire budget per cycle. And this should be fairly self-explanatory. No loans or leverage. You're just simply buying every day. And to say that you're using less than your budget is not optimal anyways. The third point is that you don't want your model to be forward-looking. So even though your challenge is going to comprise of a backtest, or in fact your challenge might simply be a backtest of how does your model perform from 2013 to 2024, we don't want you to peek into the future as you're making those informed decisions, because you're able to, you'll have all the data at hand, but when this informed decision is going to be extrapolated to new data, new unseen data, then it simply won't work, and it will be an overfitted example. So we want to be very careful about this property. It's a very important property. Lastly, when we say that we want to improve dollar cost averaging, that means that your metric, your Satoshi per dollar percentile, must be no worse than the standard uniform approach, the uniform dollar cost averaging approach, on any of the 3 cycles that are defined over this backtest period. Lastly, we're going to evaluate the models based on the highest SPD percentile averaged across the 3 4-year cycles from that same backtest period. And what you're going to be working on is the code. So you're going to begin doing some sort of exploratory data analysis to understand structural differences or key properties of Bitcoin. And then you're going to use that to motivate a strategy that will allow you to map those features that you found relevant to weights. And that will follow a very specific template that can be found in tutorial 3. Not the YouTube video tutorial 3, but the GitHub tutorial 3. And you'll be submitting your code. This is a challenge-specific detail here. You'll be submitting your code on HyperTrial, and we will be ranking your backtest. So that's all. In the next video, we're going to be going over the same problem statement, but in a much more formal manner. So if you happen to be a more quantitative-minded person, then definitely follow through to the next video where we continue through and talk about all the beautiful math that is behind this challenge.